what it says is we're going to get the area of the following regions. Okay, so I'm going to start with question 2. Now question 2 is pinned against the x-axis. So I look for the area of the x-axis formula. So the area is going to be the integral of f, b and a, and it's going to be the function, or y, dx. In this case, y equals x squared. It's x squared dx. What are my two limits? 3 and 0. 3 and 0. So suddenly the question becomes this. How do I integrate this? Well, look, we've integrated x squared enough to know that it's a third x cubed. Okay? And then we do that from 3 to 0. And then we plug it in, and we're going to get 3 to the power 3 all over 3 minus 0 to the power 3 all over 3. You wouldn't even need to put that in. We're going to get 27 divided by 3, 9 units squared. That's the area of the first curve. Any questions about that at the moment? Question 2 and question 4. Okay, now question 4 you can see has two distinct parts. A positive part and a negative part. Okay? Once again, it's pinned into the x-axis, so it's going to be the formula of BA, and then it's going to be our function, y dx. Now, I'm going to do two separate questions. I'm going to treat it as two separate questions. The first one, you work left to right, regard your, you work right to left, regard your limits. So the first one is going to be, the top one is going to be minus 2, and the bottom one is going to be minus 3, and it's going to be 4 minus x squared dx. This one accounts for this part here. What are we expecting? A negative answer, right? So and then the second part is going to be the integral of, anybody? 2 to the minus 2. Same integral again, and this time same thing. Okay, add them together. So let's find out what happens. So, and remember, you have to take the positive value for this one no matter what.
So should we put it like this?
That's what I just did there, modulus sign. Okay, so what we're going to get is integrate that. When you differentiate, when 4x differentiates into 4, and it's a third x cubed like last time, and then we're going to get a minus 2 and minus 3, and then we're going to get plus, once again my modulus sign still ever present in the background. Okay, and then we're going to get a 4 minus x squared, so it's going to be same thing, 4x minus a third x cubed from 2 to minus 2. So it's going to be very much a big calculator job here. Okay, so it's going to be 4 times minus 2. I'm just going to do this one separately on its own for a minute. So 4 times minus 2 minus a third. So we be quick on the calculator on this for me, please. Be very useful. 4 times minus 3 minus a third times minus 3 squared minus 3 cubed. Can I tell you what the red one turns into?
Minus 16 over 3?
Sorry?
Minus 16 over 3?
The full thing?
No. It's just on that.
Oh, sorry. Everything, the full part here is minus 7 over 3. But we got to remember is it's a modulus. So we're actually going to count it as plus 7 over 3. So the area of this one on the bottom is actually 7 over 3. Okay. Now what about the plus value here? So we got to do this one here on its own to the side. So we got our 7 over 3. That's not bothered there. And now we'll actually think about it. All I have to do is just change the numbers, don't I? I'll just change all of this into 2. Do you understand? It's the exact same thing, except the top one is 2 and the bottom one is minus 2. So look, I can reuse it. I'm going to say that's minus 2, minus 2. So everybody in the calculator in one go, please. So one go in the calculator, what would that be? You can reuse your calculator. This one here is going to be 7 over 3 plus 32 over 3 makes 39 over 3. 39 over 3 divided by 3 is 13. This is 13 units squared. Okay, no problems there whatsoever. Okay, let's move on. So we're going to move on to number, we have 5 and 6 here. I think you guys will be alright with the two of these at this point in time. Now, actually, there is one thing on number 6 that you're going to actually worry about. Number 6 has no limits, doesn't it not? Can you have a question?
Yeah, question.
In question 6, the problem is we don't have the extra limit. But remember, on this line here, the y value equals 0. So this means that 4x minus x squared equals 0. Take out x bracket 4 minus x equals 0. This means x equals 0. We already knew that. And then the other one is going to be 4 minus x equals 0, x equals 4. We didn't know that. Okay? Then you're going to integrate BA y dx, and then you're going to integrate from 4 to 0, 4x minus x squared dx. Okay? When you integrate this, what we're going to get is 2x squared, because when you differentiate 2x squared you get 4x minus a third x cubed, and then we're going to integrate from what's it going to be, 4 to 0. So once again, second one comes here, it's going to be 2 times 4 squared minus a third times 4 cubed, and then when you put that into the calculator, I believe it should become 32 over 3. Okay, so that's question 6 done. So on number 10, okay guys, number 10 is pinned against the y-axis. In your notes where you're leaving cert, you're going to have BA y dx. I don't have the y version learnt off by heart. All I know is interchange. Interchange means this: BA x to y. Is everybody happy with that? Now, here's the tricky part. Y equals x squared plus 2. I need to get x on its own. So what I'm going to do is actually wait a second. So what happened to me in test was I would have thought that was a y pin against the y-axis question. What I would have thought then was, look, get x on its own. So x, therefore x squared equals y minus 2, and x equals the square root of y minus 2. But on our course, is it possible for us to integrate? Is it possible for us to integrate 11 to 2? Have we done the square root of y minus 2 yet? Have we done that? No. So right now we would stop here and we would go, I've entered a part of the course that I can't do. Okay, now I can show you the way around that. Okay, using your. So we've ended up coming to a problem here where we don't know what to do here. So here's what I'm going to do. I'm going to go back to the very beginning with y dx. Alright, and what I'm going to figure out is this. I'm going to rub this out, all of this, and what I'm going to figure out is, if I get the area of a rectangle, so if I got the area of this rectangle here, do you see it? If I find the area of that rectangle, then I can obviously find out the area of the rectangle, and then following the area of the rectangle, I can get the red area against the x-axis, and take it away to find the blue area, which I couldn't use doing the y formula. Okay, so here's what happens. So, first of all, my main problem is I don't know anything about the x values. So, what we're going to say is this. We're going to say that he wants to find out when y equals 2. When y equals 2, 2 equals x squared plus 2. This implies that x squared equals 0. X therefore equals 0. We know that's the point 0, 2. Then we go to this point here, 11. This time around y equals 11. So y therefore equals 11. This makes this 11. This makes x squared equal to 9. This makes x equal to plus or minus 3. But which one is it? Plus 3. The reason why it's plus or minus 3, it's a symmetrical curve. Now, we now know the x limits are 3 and 0. We know the function to be x squared plus 2 dx. We know that we've integrated this before. It's on our course. Means we haven't made a false move. Okay, so it's going to be x cubed over 3 plus 2x, integrate with respect to 3 and 0. When you plug in the 3's, you're going to get a 3 cubed over 3 plus 2 times 3. The second part doesn't matter because it's all zeros. So what we're going to get is 27 over 3, which is 9. 9 plus 6 equals 15. That's 15, okay? Now, what we don't know is the area of the rectangle. The area of the rectangle is going to be, it's going to be 0, 11 up, and how much across? 3. 3 times 11? 33. 33 minus 15? 18. Is 18 the answer in the back of the book? There you go. Alright. What I want you guys to visualize is this. Visualize that this line doesn't exist. The line doesn't exist and it stops up here. If I get the area of the curve, I get the full area, this full blue area here. Do you understand? Because it's the curve all the way down to the x-axis. What I have extra is this green triangle here. So I'm going to get the area of the curve as if the line doesn't exist. Then I'm going to take away that triangle. Okay? Now we can do this two separate ways. I'll show you. Now, you could get the, we have to figure out where does this curve hit the x-axis. When it hits the x-axis, y equals 0. This leaves 0 equals 6 minus x squared. Bring it over one side. And then you're going to get x plus 3, x minus 2 equals 0. Then you're going to get x equals minus 3, x equals 2, Rory. So minus 3 and 2. Happy enough with that? Next thing I got to do is I got to figure out where does the line hit the graph. Now, when the line hits the graph, it means that the y value of the curve value equals line value. So what this means is y equals y. This means that 6 minus x squared equals x plus 3. We've done this in chapter 1. Okay, move it over, we're going to get x squared plus x, and then we're going to have what's it, 3 minus 6, which is? Yes, I knew I made a mistake there because I wouldn't have been able to solve it otherwise. 2x minus 3. Once again, solve, and we're going to get x plus 3, x minus 1, and we're expecting the answer x equals minus 3, aren't we? The reason why we're expecting the answer x equals minus 3, where the line hits the curve, it also happens to be the x-intercept, the x-axis intercept, okay? And this value here is going to be 1. So this value here is x equals 1. Okay? Now, we have our limits. Our limits is going to look like this. We can do this two different ways, okay? Now, the first way you could do is you could find the area of the triangle quite easily, couldn't you?
Yeah.
Because the base is going to be minus 3 up to 1. What is minus 3 up to 1?
4.
4. It's going to be a half. 4 times, what's the height? The x value is 1, which makes the y value 4. 1 plus 3 is 4. So it's going to be a half 4 times 4, which is 8. Keep that in mind because I'm not actually going to do it that way. Alright? So here's what we're going to do. I'm going to pretend, like I said earlier, that the line doesn't exist. I'm going to get the full shaded area here. This full shaded area is going to be minus 3 to 2. It's going to be 6 minus x squared dx. I'm then going to take away, 8, haven't I? But here's another way of getting 8. It's the area underneath the curve here. So it's going to be, once again, oh sorry, that doesn't go to 2, it goes to 1. Because it stops up here. And so this is going to be 1 to minus 3 as well. And the y value is x plus 3. So do you see that? And this here should turn out to be 8. Let's find out what it is. Okay, integrate. When we integrate, what we're going to get is 6x minus a half x squared. Because when you differentiate, it turns back into its original. Okay, and then you're going to get minus a third x cubed. Now I need some guys to be on the calculator for me in a second. Minus, it's going to be a half x squared plus 3x from 1 to -3. So if somebody could be so nice as to take care of the blue box, and if somebody can take care of the red box here, you'll see it now in a second, okay? So what's that? 1 and -3. So I'll multiply it out now, okay? So here's it written out longhand. 6 times 1 minus a half, 1 squared, minus a third, 1 cubed, minus, open bracket, 6 times -3, minus a half, times -3 squared, minus a third, times -3 cubed, close bracket. That's the red part only. The blue part is going to be a half, 1 squared, plus 3 times 1, take away, open bracket, a half, 1 squared, plus 3 times 1, close bracket. So, the value of the blue one, or the triangle, is 8 as predicted, and the red value,
I'm so close right now.
okay, put that, 56 over 3 according to the red, take them away from each other, and we get 56 over 3 minus 8, which is 32 over 3. Sounds familiar. Very familiar number in this exercise. Okay, now, does anybody disagree with that?
No.
Okay, moving on. Now, next ones, okay? The next ones are different in the following ways, okay? So you go, find the area of the bounded region enclosed by the curve y equals 5x minus 2x squared, and the line y equals x. Well guys, what we're going to do here is, I'm quickly going to put this into my calculator, and I'm going to get a quick graph of it. Now, I have no idea where it crosses the x-axis yet, but I know what type of shape is it. N shape because of the minus x squared. If I put y equals 0 down, what does y equals 0 represent? Where does it cross the x-axis? So what I can do right away is I can figure out where does it cross the x-axis. So where does it cross the x-axis? If y equals 0. If y equals 0 equals 5x minus 2x squared. What we get then is we can get 0 equals x brackets 5 minus 2x, x equals 0, or 5 minus 2x equals 0, 2x equals 5, x equals 5 over 2. It's going to be 0 and 5 over 2. It's an N-shaped curve like so. Okay, and that's it done. Okay, upon completion of that, okay, so what happens here is we get the line y equals x. The line y equals x is something like that, and now we're going to have to get the area enclosed. Okay, and there is